Great.
This meeting is being recorded.
Hello, everyone. Welcome back to another edition of It Depends podcast series. AlloyDB, if you haven't heard the name before, you're in for a great surprise. It is Google Cloud's newest database management offering based on PostgreSQL. Today, we have the pleasure of talking to Andi Gutmans. He is a visionary in the space of data management. If you remember the LAMP stack, which was Linux, Apache, MySQL, and P stood for a number of languages. One of those languages was PHP, which he co-created. Today, he's more known as the general manager and vice president of engineering for Google Cloud Databases. So great to have you, Andi. He will take us through the launch of the new database, its value proposition, key capabilities, differentiation, strengths, and direction roadmap. One quick fun fact that I like to insert into my podcast, Andi is truly a global citizen. I was quite amazed to find out that he holds 4 citizenships, 4, American, Israeli, Swiss, and British. I didn't even know that was possible. Andi, thank you so much for taking time from your busy calendar to talk to us. Welcome to the show.
Thanks so much for having me.
So, Andi, to get started, I did a very high-level introduction, but I'm sure you have a lot more to add. Can you please introduce yourself and give us some color into what you do and what your journey has been up to this point?
Yeah, absolutely. So I'm Andi Gutmans. I run databases at Google Cloud. I also run some of the internal databases that we consume in the Google businesses, such as Spanner and Bigtable. And I've been at Google for 2 years. I would say my journey started in the late 90s when I started to work on PHP, the web development language. So really I've been in the open source space for most of my career and serving developers. So just always have had a huge appreciation for the developers, the builder persona and what it takes to really build kind of new user experiences. And I was basically in that space until about 2015. We founded a company called Zen, which was kind of the, like Red Hat is to Linux, we were to PHP. Sold that in 2015. And then after that, I joined AWS databases. I had always been on the developer side, but I did a lot, had a lot of interaction with the database side through client drivers and APM tools and so on. And really, was excited about actually moving into data as I realized how valuable that was. And so got a lot of opportunity on the non-relational side to build new databases, such as Amazon Neptune, which was a graph database, then moved to the analytics side. And then 2 years ago, I joined Google. Really what attracted me to Google was just this heritage of innovation around data and really having built some of the most differentiated, databases that exist, just given the nature of the huge Google businesses, right? Multiple billion user businesses. And there was really no other data stores that could support that. So just the way Google has been innovating, the systems it's built, and so been here for 2 years and just really excited about that. And as you mentioned, next week, or actually I say now, we just announced the AlloyDB, and just super excited about that. It's really the biggest database announcement we've made since Spanner in 2017.
Oh, wow, 5 years. So Andi, when you joined Google Cloud, you were, if I remember correctly, were only responsible for the operational databases. Do you now have oversight over both operational and analytical?
No, I continue to focus on the operational database side. So I have a peer that basically does analytics. We obviously work super closely together because customer journeys kind of span operational, analytical, and machine learning.
Right.
But definitely a big part of what we're focused on is, how do we make customer journeys seamless? And the fact that I've done analytics in the past is kind of, helpful in those conversations.
So my question right off the bat, why do we need another database? Don't we have like 300 databases on DB engines? So why a need for a new one? Especially because in Google Cloud, you already had the Postgres capability through Cloud SQL and Cloud Spanner, which are both PostgreSQL compatible. So what is it that the customers have been asking for that prompted you to to build a new database?
Yeah, that is a great question. I would say that, let me kind of, take a step back and talk about the journey we had in databases, and then where we really see AlloyDB fit in. So, as I said, our heritage is really around, innovating on data at scale, building the most highly available systems, building the most scalable systems. And that's where you see the technologies like Spanner, Bigtable, Firestore, which, by the way, Firestore is actually built on top of Spanner, which is why it's got this high availability and scale.
Right.
That's been really, a big strength of Google Cloud. And we get a lot of customers, right, who basically choose Google Cloud because we have database offerings on the transformative side like no one else has. But as we focused on supporting our customers' journey to the cloud more, and especially enterprise customers, it became very clear that we also have to support the lift and shift journey, right? Because it's a multi-step journey to transformation. You migrate, then you modernize, then you transform. And so that's where we launched and support Cloud SQL, right? With support for SQL Server, MySQL, and Postgres. Of course, bare metal solution for Oracle, Redis on Memory Store. So those are kind of the lift and shift workloads. And so you're right that we have great fully managed service for Postgres and Cloud SQL. We have just recently announced a Postgres interface for Spanner.
Correct. Yeah.
Okay? But what we really been hearing from customers is they're trying to accelerate moving from the legacy proprietary databases onto open source for lots of different reasons, right? One is open source just gives them the biggest flexibility. In many cases, there's also unfriendly licensing terms and business practices attached to some of the legacy databases. And I would say that kind of de facto standard database in enterprise right now on the open source front has been Postgres, right? Postgres is just going super quickly in enterprise.
Yeah.
Yeah.
No,
and,
please.
Sorry, go ahead.
No, after you. Sorry.
Yeah, and that's because Postgres has just such a strong affinity, right, to folks who are coming from the traditional databases with all the different features it has, like store procedures and triggers and the data types and so on. So it's become very clear that, number one, customers are trying to move on to open source. 80% of enterprises at least are running on multiple clouds, so they want that flexibility of open source. Yeah. Postgres is kind of that best migration target for them. And, with over 70% of new application development being on open source, 50% of legacy databases already being either migrated or in the process of being migrated to the cloud, right? That's kind of where the customers said, okay, we have Spanner for a lot of these transformative new customer experiences. It's not, by the way, the goal is not for it to be 100% Postgres compatible. It's to make sure that the Postgres interface gives customers a more familiar interface and access to tools and frameworks. Cloud SQL is a great fully managed service, has been incredibly successful and grown really fast. But as we're talking to them about the very high end of enterprise transactional services, right? That's where we see AlloyDB fit in. AlloyDB is basically a Postgres on steroids. So it's all the full compatibility, supports 50 extensions of Postgres. So it's 100% Postgres compatible.
Right.
But in areas such as security, reliability, performance, scale, manageability, we've gone that extra mile to really make sure that when customers bring their most mission critical databases to open source, right, we're able to give them the best landing spot.
So I cannot wait to get into the innards of, what is that execution engine? So you have a fully compatible open source Postgres, and then I saw there was mention of best of Google. But before we go and start drilling deeper into the technology, I saw from what was announced that there's a row store and there's a column store. So can we at least, before we go into further details, is this an operational database, analytical database, or an HTAP that combines the two?
That's an awesome question. I kind of think about it as an HTAP system, but I'll talk more specifically about, what it does and what it doesn't do, right? Just to be very clear. So as I mentioned before, I've been in the analytical space. I've been in the transactional space. One thing is very clear, right? Like the world is kind of starting to converge a bit. Customers want to make real-time decisions on transactional data, whether that's for fraud, whether that's for recommendations, whether it's for inventory management. So very, very important to be able to access the transactional system and data to also drive real-time insights. And so one of the opportunities we saw is, if we actually take Postgres, but also extend it much more into the analytical space, right? Now customers can actually also drive some of those business insights in real time on their transactional store. That's a pattern that we've seen over the years, but it always breaks down a bit because the raw stores can't really provide the performance and analytical queries. And so using machine learning, we're basically learning, what are the columns that customers are really driving analytics against. And then we take those individual columns and we convert them in memory to a columnar store. And that's how we're able to drive up to 100x faster analytical queries on AlloyDB. Now,
how long is that latency between row store and column store?
So it's actually immediate. It's transactionally consistent. I see. Because what we're just going to do is we do compensation if we need to. So we can do the majority on the columnar store, and if there's a new transaction coming in, we'll do the row-based compensation. So customers can really trust it and actually depend on it.
So, Andy, if I have a SQL statement that says select star from a table where ID equals something and another where clause, that to me is more of operational. But if I have a select count star or something, group by something like that, what happens in AlloyDB? How does the engine know whether to go to a row store or to a column store? Who's making that determination?
That's a great question. So, really kind of the query planner. As I said before, most likely if you're doing that, you're probably quite interested in the column, multiple times. So we basically learned that that's a column that you really care about. And so we will, we'll put that in memory. And then in the query planning, we'll basically say, okay, why don't we go through the columnar engine versus the row-based engine? And we actually use vectorized scanning. So we use kind of the SIMD instruction set to be able to process that data in memory extremely, extremely efficiently.
And to understand or predict which column would be needed next, is there a lot of machine learning being built into the product?
Yeah, I mean, it's a combination of machine learning and a bunch of heuristic algorithms, but absolutely, I think that the smarts of figuring out which columns do we choose to put in memory, when the query plan do we choose to go to the columnar store versus the row store, and just making that kind of a learning and ever tuning system, and then also driving the compensation as transactions come in. It's actually, it's a very complex system. We worked quite a few years on this to really get it right out of the gate. So we're super excited about it.
Very nice. One thing I noticed in the release was that you are bringing, within quotes, the best of Google to the PostgreSQL ecosystem. Can you please add some color on what is the best of Google?
Yeah, no, absolutely. It's a great question. We build systems in a very unique way at Google. One of the things that underlies all of our services, including BigQuery and Spanner and all the applications we run at Google, is the fact that we've really disaggregated compute and storage.
I see.
Lots of folks talk about compute and storage separation, but the reality is within the storage system, compute and storage are still very tightly coupled. Right. The way we build it is we actually have, disaggregated storage, disaggregated compute. We have the world's, best network, and we run our backbone. And so as we start to think about AlloyDB, right, we're actually building it on those primitives. And so that, as we've offloaded the storage system onto a distributed storage system, right, that distributed storage system is actually completely disaggregated compute and storage. And so we can be extremely smart and intentional about how much compute we have to, we have to actually throw in a specific problem. So it just gives us a lot of flexibility, which has really helped us gain that, that edge from a scalability perspective and performance. In addition, we're really a world leader in machine learning. And so we have a lot of machine learning experts. And so really thinking about how can we apply machine learning in the database, right, to really deliver that kind of autopilot system in the best possible way, is also part of what I would kind of call, Google's, one of Google's big strengths.
So you've got scalability. You mentioned machine learning. What about the file system? So you've disaggregated compute and store. So there are many nodes for compute. So is it a shared file system? And what file system is that?
So we, I would say the way the innards work in our environment, I mean, it's something we call Colossus internally. I believe we've published some papers about it, but it's basically a completely multi-tenant distributed storage system. One of the things that I think is very exciting about it, when you look at kind of competitors and what folks have, they tend to look at these blob stores that have the tens of milliseconds of latency.
Yeah.
These are sub-millisecond latency, so they're really in the microseconds. And so given that we have a lot of flexibility now on where we place the data, how we attach compute to it, as we offload the write-ahead log to the storage system, as we replay the write-ahead log, we don't have as much issues as other vendors may have of dealing with like hot partitions and so on and so forth, because we can actually very, very dynamically adjust to the workload.
Andi, I am probably going off script here, and I should probably not mention, but for our viewers who are watching this, I am sure this question is coming up in our people's mind. This seems like Aurora, like what AWS did with Amazon Aurora for PostgreSQL and MySQL. What would you say to that?
Yeah, I think a couple of things. I mean, I think, Aurora has been a very successful product in the market, and it's actually just the validation, right, on how much enterprises have been, trying to move off the legacy databases and onto open source. I think there's a lot of uniqueness in AlloyDB and how we built it. So if you look at other vendors and how they built their system, it is with the storage compute separation. I think that the fact that we have these completely disaggregated gives us a lot of strengths. We also took a Postgres kind of focused approach, meaning, others kind of started with MySQL, then added Postgres on top of it. I think just this focus, this relentless focus on Postgres just really helped us, build the best Postgres compatible service that's out there. As a result, right, we're 4 times faster than open source Postgres based on our benchmarks. Based on our benchmarks, we're 2 times faster than Amazon's alternative. So I definitely feel like, we've really purpose built this. And then also we've done some of these special things around extending to analytics, integrating more machine learning. So
that's very interesting.
I feel like we're really going to market with something that's very, very unique.
If I may ask, will there be an AlloyDB MySQL, or will it be always Postgres?
Yeah, right now we're really focused at like solving that middle ground that I mentioned, like the modernization area. And when you think about customers either coming from legacy databases wanting to modernize on open source,
right,
or just high-end Postgres, applications that need a bit more, Postgres is really the piece that we feel is most critical in that area. We do have a great offering, Cloud SQL for MySQL, where we offer MySQL. I've been in the industry long enough where I would say never say never.
Yeah.
But we definitely heard from customers that like the most critical thing for them right now is their ability to modernize their kind of proprietary databases, get onto open source. And that's really the problem that, the key problem that we're trying to solve with AlloyDB.
I have a question on the last point you made before we talked about, the future plans of AlloyDB. And you were saying, you're talking about machine learning. When I think of machine learning in a database, I think of 2 sides of the coin. One is the internals, where you mentioned autopilot, where you're doing, I guess, automated memory management, workload management, probably automated vacuum management. Okay, so that
Yeah.
is the engine. But then the other side is where I have the ability to write a SQL and call a machine learning model, a pre-built model, to, let's say, do sentiment analysis.
Yeah.
Can you talk about the second half, the integration?
Yeah, no, you're totally right. I mean, those are exactly kind of the two categories that I would also describe. So we actually integrated AlloyDB with Vertex AI. Vertex AI is our machine learning platform to do exactly what you said, right? The transaction is coming in. You want to look for, you want to do fraud detection, recommendation, sentiment analysis, and you can actually inference within the same transactions. Some would call it an augmented transaction. So we absolutely allow you to combine SQL and transactional with actual machine learning inferencing within the same transaction. So I think there's a lot of opportunity there for customers, right, to really do some of the machine learning in line to the transaction system.
I love this whole integration and sort of colliding of the databases and the machine learning piece, because in the past we had to take the data out of database into an ML cluster, and now you're making copies. And if you have hundreds of terabytes, petabytes, that just gets too difficult. So do you see that this integration happening more and more?
I definitely think that you see that integration happening more and more. I would caveat though that when you want to train your models on a large amount of data from different sources, right? Very often you would actually use like BigQuery, right, to be your aggregation point for multiple systems, right? And then based on that, you would actually go and train your model in Vertex AI, right? The nice thing here is though, then you can actually call that model from AlloyDB.
In SQL, right? As a user-defined function.
In SQL, yeah. So I would say that absolutely you're going to have some models that get trained directly from the operational store. Yes, correct. But I think if you want to complement it with, data that's either ELT'd or ETL'd from a variety of systems, it's awesome work that has been done on the BigQuery team to really make that kind of integrated ML experience super powerful.
Got it. Changing tracks here, Google has been quite vocal about supporting a more open and multi-cloud approach with their offerings. For example, BigQuery Omni came out some years ago. How does AlloyDB support that open multi-cloud approach?
Yeah, no, you're spot on, right? Over 80% of enterprises, are going to be using more than one cloud provider. And, no one wants to migrate databases to a new database and be locked in again. So for us, it was really critical, given that we really pride ourselves as being the most open cloud, to make sure that, AlloyDB is really 100% compatible with Postgres. And that is not just SQL dialect compatible, that is compatible in every sense, like wire protocol. We support over 50 popular Postgres extensions, including PostGIS, which is super popular for the Postgres community. So we wanted to make sure that if someone comes in AlloyDB, they can lift and shift and run this on Postgres in a different cloud, on premises, on their laptop, at the edge. And that's really been a core tenet. And that's really a big focus of ours, is being the trusted cloud provider that really meaningfully invests in customers' choice on where they want to deploy.
And multi-cloud, how is that supported?
So multi-cloud, I would say, AlloyDB right now, because it is so, intertwined, right, with some of the Google systems that I mentioned.
Correct.
AlloyDB coming out of the gate is going to be, just available on GCP.
Right.
But you don't have to make any code changes or any changes to move your application onto managed Postgres somewhere else. You'll have some different performance characteristics or so on, but that is our commitment. Definitely, we continue to think about, are there other ways we can make it easy for customers, right, to manage their data across different clouds? You mentioned BigQuery Omni. This continues to be a space that we think about on what else can we do for customers to provide the portability and flexibility.
I have one interesting thing that stood out for me when I was just trying to understand AlloyDB. And that to me, that sort of harkens to multi-cloud to some extent, kind of indirectly. But when I look at some of the other Postgres implementations on other cloud providers, they'll make a backup in their own format, but you use PG logical, from what I understand, which means that backup, I can restore it in any location, because that is a true Postgres backup.
Correct. And, we do, I would say we give a combination, right? We both give you kind of the, logical Postgres, both replication capabilities and then also backup. And so from that perspective, we want to make sure we really support kind of openness and enable customers to take their data wherever they want to. Of course, in, systems like AlloyDB, that also opens up opportunities for us to, create, additional ways to do backups, right? That can provide some additional customer benefits, but that does not come, it doesn't come, it comes in addition to the open kind of backups and replication that we enable customers.
That's great. Now you've opened up a whole box of like replicas and so high availability, business continuity. But before we go there, I have a question. I want to go back to, you've been talking about 2x, 4x performance, 100x for analytics. So we've been seeing these impressive performance benchmarks. How are you delivering that? What are some enhancements? I saw there was some use of NVMe cache, for instance. So can you talk about what is the secret behind all these enhancements?
Yeah, so lots of secrets. It's it took a lot of work and a lot of projects to kind of get to these numbers.
Right.
And we don't share these numbers lightly. I mean, it really just is just great engineering. I think it's everything from how we offload the logs, to the distributed storage system. Then in itself, we've done quite a lot of work on the write-ahead logging side, with to really make sure we get the best performance. Quite a bit of work on things like the query processing, including enabling scalability. So actually, Postgres and the majority of databases don't have linear scaling on a vCPU basis. We've actually made some significant changes. We're actually driving linear scaling up to 64 vCPUs. So that's really,
for read and
part of the open source community. But we also did scaling, quite a lot of scaling work. And then I would say that, in addition to that, just work on things like you mentioned, like multi-tier caches and making sure that, we can really, fetch data that may not be in memory, a microsecond latencies as opposed to millisecond latencies.
And what sits in NVMe cache? So you got the row store, the column store. What goes in NVMe?
So I think, there's, but, it's primarily, I would say, kind of on the row side, because our columnar cache today is an in-memory cache.
I see.
As you can imagine, the sky's the limit.
Yeah.
And it does open up a lot of opportunity for us to continue to innovate on this front. And so my answer may change, over time. But definitely, I would say kind of the, caches are super useful, when it just comes to the core data.
What is the impact of these enhancements on the cost factor? What can users expect? And then my second question about cost predictability, which has been a very sort of a tricky topic about predicting how much it's going to cost. So cost and predictability.
Yeah, great question. So let me touch on cost first. I would say that, given that we have linear scaling on the vCPU basis, and we have kind of this, 4 times faster than Postgres, capability, and then the analytics capabilities, we definitely believe that we're market leading from a price performance perspective, right? And so for customers, there's a real opportunity here, especially as, as they've been using bigger instances of Postgres. Not only are they going to get the benefits of all these other things we've talked about, but the linear scaling can actually make a very significant impact.
Yeah.
So that I would say is on the cost side. The other feedback we got on how we actually price is, I won't talk too much about like the expensive, proprietary licenses, because I think we all understand they're very expensive.
Yeah.
But the other feedback we got is, as customers were looking at other alternatives in the cloud, they would have these opaque IOPS costs. And that's not really a cost the customer easily controls, because it's all dependent on what's in the buffer cache, what isn't. And customers really value cost predictability,
I
right?
see. Yes.
And so that's a problem we set out to solve. And so in AlloyDB, what's really special is we actually charge you on a compute and storage basis. We do not charge incrementally for IOPS. And so we're basically just taking the risk. If a certain workload just is driving way more IOPS, we just take the risk on the workload. But it really solves a key problem that our customers have raised to us, is that they just didn't like these opaque charges. And there's definitely been situations where we've heard that these charges can get up to 60% of a customer's bill. So these are not minor, depending on the workload, they can add up to be very large, but the customer feels like they're helpless because they can't really control it.
Yeah, very interesting. So you're only charging for compute and store, not for IOPS.
Correct.
I see. And do you have approximate numbers, like in terms like a similar workload on another Postgres? How much lower will it be in AlloyDB?
We have, we obviously, as we kind of talked about pricing and how we built this, I have some numbers, but I don't have them at the top of my head. But definitely our goal was to be extremely price competitive.
I see.
And as I said, not just price competitive, but also the least amount of friction for customers to figure out how much it's going to cost them.
I am curious about the ecosystem. So you've got AlloyDB, which is a very good operational database with analytical capabilities now. But for some use cases, customers will still use BigQuery. Yeah. So what is that connection between AlloyDB and BigQuery? Is it like PubSub or Cloud Data Fusion? And what's the ecosystem?
Yeah, let me describe what we're doing with Cloud SQL, and then you could imagine that we're going to do something very similar with AlloyDB over time. So, for example, we have a service called DataStream that we launched, which is a change data capture service, and that basically enables you to capture changes from things like MySQL on Cloud SQL, and ingest those into BigQuery. And there's a very robust roadmap on that front, and it's going to become easier. So you can definitely imagine that the same way we're going to do Cloud SQL, you're also going to have, AlloyDB change data capture. That's if you want to move data in that way. Yeah. The other thing we have is we actually have federation from BigQuery to Cloud SQL, and customers actually query up about 125 petabytes a month from BigQuery to Cloud SQL. And so, that same experience we're also going to be bringing over time to AlloyDB. So I would say, kind of on the data movement side, those are probably the two key things I can talk about today that you should be expecting. But given that, the disaggregated compute and storage, how we build our systems in a very unique way, you can imagine that over the long term, there's a lot more opportunity for us to innovate.
Got it. So this other direction you mentioned, BigQuery to Cloud SQL, this is you run a federated query to get both historical in BigQuery and operational in Cloud SQL? Is that
exactly? So you can run a federated query based on the query you ship to Cloud SQL, and then mix that also with a query on BigQuery-based data. And actually, as we've talked about Big Lake, right? That also includes data in the data lake.
Yeah. So can you talk more about Big Lake? Just for people who are still.
Yeah. So Big Lake is basically our focus on really bringing the analytics ecosystem together. So customers love BigQuery. They love kind of going into the front door of BigQuery. So we said, why not just make BigQuery the landing spot for customers, and then give them the choice, not just to query their data in BigQuery, but if they've got open formats, in Parquet or ORC in their data lake and GCS, if they're using things like Iceberg, can we make that as simple as possible, right? To also use BigQuery to query the data in the data lake as it is. in BigQuery. So that kind of, is the beginning of BigLake, but you can imagine that it's also includes security and governance, and then enabling, different engines, whether it's Spark or the BigQuery query engine or Presto, right? All being able to access and query the same data. So, we're really trying to simplify the analytics landscape for customers.
Yeah.
And customers are really excited about the announcement we made in BigLake, I think about 3 weeks ago.
I see. That's great. Andy, we've talked about scale, we talked about cost, we talked about performance. Now I'd love to learn about high availability business continuity features like DR, backups. Can you talk about what's interesting in AlloyDB from that aspects?
Yeah, absolutely. And I would say that, given that we really targeted AlloyDB to be able to support the most demanding enterprise applications, right? Availability, of course, and data protection, right, were kind of top of mind. So we knew that, we couldn't migrate a customer who's on a very high-end, kind of highly available system and not provide, comparable or better availability on AlloyDB. So from an availability perspective, out of the gate, we're at 4 nines availability. That includes maintenance. So that's our availability SLA. We are able to do maintenance in a matter of seconds on the primary. On the replicas, we actually are able to do 0 downtime maintenance. And so really from an availability perspective, we're really best in class and are able to compete on the highest end workloads. I would say from a kind of data protection perspective, all the things that you would expect, whether this is backups, multi-region replication, point-in-time recovery, we had to, of course, make sure to be a credible enterprise database that we had to check the boxes checked, on all the different data protection capabilities that customers expect.
One of the big issues I talk to customers is when the cloud provider says, sorry, there's a new patch, the entire region is being upgraded or the entire availability zone. You don't have a choice. There could be a freeze going on, and the database is down. It's planned maintenance, so it doesn't even consider towards SLA. So what is something unique about AlloyDB when it comes to upgrades and patches?
So the first thing is that we are actually very unique that we actually provide this 4 nines SLA inclusive of maintenance, meaning we actually stand behind it, including maintenance.
Wow.
We give customers a lot of flexibility on how to decide when they do take maintenance, including maintenance deny periods. Because if you're a retailer and there's Black Friday, Cyber Monday coming on,
right,
you don't want any maintenance. Even if it's a good patch, you don't want it, right? So we're basically giving customers a lot of flexibility around that. When we do maintenance, as I said previously, I would say we're really market leading on a low, seconds that we need on the primary. And then on the replicas, we're actually able to do kind of 0 downtime maintenance. And so that, I think that experience is really, really critical to AlloyDB's enterprise value proposition.
Got it. So, I had so many questions on upgrades and backups, but I really like this. Your 4 nines includes planned maintenance. That's a big differentiator in my mind.
Yeah, because some providers are like, well, we're going to exclude maintenance, but frankly, a retailer doesn't have a maintenance window in their business, right?
Correct.
So, our goal is really to align with, the business requirement of the customer, and their business doesn't have maintenance. And so we really want to make sure that we deliver best-in-class experience.
What is the version of Postgres that is being delivered with AlloyDB?
That's a great question. One of the feedbacks we got from our customers is, they love Postgres. They want us to always be current with open source Postgres. And so we really, engineered this in a way so when a new major version comes out, we can get to that major version in a relatively short period amount of time. So we're actually launching this public preview on the latest version of Postgres, which is Postgres 14. Yeah. We started on Postgres 13. And it took us a relatively small amount of time to get to Postgres 14. So there's a very strong commitment from us to kind of continue that focus on providing, latest versions of Postgres so customers can really also benefit from all the innovation that's happening in the community.
Got it. Yeah. So directionally, you are looking to quickly upgrade to the newer versions of Postgres as they come out.
Correct. I mean, you always want to, given it's an enterprise product, you want a bit of bake time in the community just to make sure, it's good. But we're talking about matter of weeks. Our goal is not to take a year or two to get the, new version supported.
But as a customer, I have a choice, right? I can say, well, I'm going to stick to Postgres 14. Even though, let's say 15 has come out, you're not forced to migrate.
Yeah, I'd say, in general, we're very, very careful in deprecating technology for customers. This is really a big transformation that's happened in Google Cloud over the past 2 years, where, we have a very strict focus on, making sure we minimize deprecations, doing what's right for customers. And so, I can't say never, never say never, because you never know what happens from a security perspective and in the market. But definitely our intent is to, follow where our customers want us to go from a version support perspective, and really make sure that they can, trust us and depend on us.
I see, got it. So I have one last question on technology, and then we'll change tracks. We're getting close to the end. We haven't talked too much about automation. Can you touch upon the automation features of AlloyDB?
Yeah. So, like any fully managed service, of course, in the cloud, it's API driven. You can drive the service in multiple ways, whether it's command line, API calls through the console. But I think, part of the core differentiation we have is we decided to, combination of, algorithmic heuristics and machine learning, is to really make this more of an autopilot system, right? So things that, Postgres users don't always like doing, like trying to figure out when to vacuum, kind of figuring out the limits on the memory between storage, buffer pools and memory management, how to tier data, the analytics acceleration we talked about. So we've really built a very intelligent system that basically, is like an autopilot, for customers. And so the goal here is to make sure that, we are really doing a lot of this automation under the hood for customers, so they don't have to take care of it themselves.
That's great. Andi, your deep dive has been fantastic. It's really great to see all these new things that are coming out. Cannot wait to do some hands-on work. I would like to ask you a few questions. We do this at the end of our podcast where we talk about some of the, leadership kind of topics. Would you mind sharing how the last 2 years of lockdown have been? What are your leadership principles, and how do you keep the team motivated and going?
Yeah, great question. I'll first answer it in the context of the past 2 years, and then I'll talk about it in general. I onboarded at Google in May 2020. So I basically onboarded virtually. So, for the first couple of years, I barely met any of my employees in person.
Oh, wow.
And it definitely created a new kind of leadership challenge, right? Like, how do you take care of people? How do you connect with people? How do you understand the nuances in communication? And so I think definitely my leadership style, kind of evolved, like I'm sure it has with many people, on just finding, more room and time and space for people to connect with people, even if it's virtually, and really try and understand what people's kind of desires are from a career growth, from an impact perspective. And, I'm not going to lie, it's been hard. I mean, it's definitely not been as easy. And, now we're starting to go back to the office, and it's just so much, it's such a joy to actually meet people in person and kind of have the more casual conversations. So I think that's how it's kind of been interesting over the pandemic and joining Google. I think from a leadership style perspective, what really drives me is, seeing people's growth. I always say, like, the older I get, the more I realize that my real legacy is not the technology I leave behind, but really the leaders I leave behind, right? And so my goal is to make, some form of contribution
Yeah.
in helping just people's careers, helping coach, being there to kind of, grow people's skill sets and so on. So that's been that's I would say is probably the thing that's most important from my perspective. And that means that in areas such as, building the right teams, helping teams, drive kind of unbiased and inclusive decision making. That's a big part of, that's something I get very excited about. And then also just kind of help instill this engagement and ongoing curiosity about technology and innovation and customers is really important. And while I said customers last, I always start with customers. Like in every conversation we have, it shouldn't be about theoretical benefits to customers. It's all about what are customers asking us for, how are we seeing them use technology, and what can we do to make their lives different. And by the way, that's how we ended up with AlloyDB. I would argue it's a very tactical thing. Like, we just listen to our customers.
Right.
No, it's we ended up, I think, listening really well, and I think we're coming out of the gate with something extremely innovative. But it's really something our customers are trying to do, and I think it's an opportunity for us to help them.
It'd be interesting to see, between now and Google Cloud Next, which, if I'm not mistaken, I think is October 11th to 13th. So, like, what is the journey of AlloyDB in terms of customer? So we should probably talk again at Cloud Next and see how AlloyDB is doing. So.
Absolutely, I would love to talk to you again. I mean, we've been in this private preview for the past few months. We've already gotten some good customer feedback. I imagine that's just going to amplify over the next 6 months. By the time we get to Cloud Next, maybe that's a few less. So I'm sure I'm going to have some really interesting updates on what we've learned, since launch, and we're really excited to, just hear from customers and see what we can learn.
How's your travel situation for this year? Are you starting to travel again?
Yeah, I started to travel. Last week was actually the first time I got to meet my New York City team, which was awesome. It was my first official business trip at Google. And
wow, the very first.
We have an awesome team there, and then next month I'm going to Seattle because we have a significant team there.
I see.
And so my goal for this year is to really try and catch up on meeting my team. Obviously, customer travel will then follow. But right now, just getting to meet my team in person is a top priority, just given I've been here for 2 years and really haven't had that opportunity.
How do you keep track of all your 4 passports? It's like, by the way, is there a record? How many passports somebody has, the maximum number of passports?
It's a great question. I don't know. I've only met one person in my life that also had 4. So I'm at least the second person that I know.
I see.
That is 4. But, by the way, the way I got to this is like British mother, was born in Switzerland to a Swiss, Swiss father, moved to Israel when I was 10 and then moved to the US.
I see.
What I do is I actually travel with all 4 and I optimize based on how long the line is. So, with some countries, you have to use the local passport to go in. But if I go to Europe, there's the EU line, there's the general line. Sometimes the EU line is actually longer. So it's an optimization game.
Yeah. Wow. It reminds me, I was flying with my family. We had gone traveling we flew from Addis Ababa, Ethiopia, and we were coming back home, but we were on United Airlines Star Alliance plan. So we had to connect in Israel, in Tel Aviv. And when we showed up, they were not expecting us. They had no clue. It's like, why would anyone ever transit in Tel Aviv? Complete confusion. Finally, we had to enter the country, exit the airport, enter the country, and then enter back into the airport. So long lines, yeah. So, yeah. So, Andi, one last question. Tell us something about yourself that the world doesn't know in general. Something fun.
One thing that some people know, but I don't think the general public knows quite as much, is I'm a hobbyist barista. So I love making coffee. I do latte art. I've used YouTube to basically continuously to get better and learn how to do latte art. So I can do a leaf, I can do a heart. I'm not the best. I'm still learning.
I see.
That's something that's kind of a hobby that I can do in a very small amount of time. Plus, it boosts my productivity at work. So it's a win-win.
That is great. That is so funny. Yeah, anything to boost your productivity, because the problem is that we are inundated with so much. In fact, that was one of my questions that I wanted to ask you. It's like, how do you keep up with this torrent of technology? It's like every day there are like 50, 100 companies in every category. What do you do to keep up with all of this?
I think it's really hard. I mean, I wouldn't say that I'm able to keep up with everything, but definitely, I've got some awesome folks on my team, who keep up. And so in meetings and so on, I get a lot of value just from meeting with the engineering team and the product management team and so on. So I would say my team definitely being at the forefront, teaches me a lot. I also try and read as much as I can, both on social media and in other places. Watch some YouTubes at 1.75x so I can
Yes.
compress the time frame from when I get the data. But I think it's getting increasingly hard for everyone, right? There's just so much information, so much innovation out there, but that's what makes it exciting to be in tech.
Correct. Yes, very true. Andi, I want to thank you so much for coming on this show. It's been an absolute pleasure. I cannot wait to see more about AlloyDB and the whole ecosystem. So thank you so much. This was a fantastic.
Thanks so much for having me.
You're welcome. Thank you.